Science in pajamas. Alright, today we're going to take our understanding of vectors in two dimensions and take it to the next level. So last time we were talking about how to solve for a resultant and how to break a resultant into its x and y components, also known as resolving the resultants or resolving the vector. Well, what if it's not quite as, straightforward as that? What if it's a little different? So here we have a problem. We have roller coaster moves 70 meters horizontally, then travels at an angle of 30 degrees above the horizontal. What is the displacement? So we're still looking at the displacement, and that includes direction. But this is a little bit different than ones we've seen before. What we're going to talk about today is how to add and subtract vectors. So let's go ahead and diagram this. It moves for 70 meters horizontally, and then it changes and moves 30 meters above the horizontal. So that means that the angle is 30 degrees. So that's what our problem looks like. And what we want to find is, we want to find that, as well as the direction. Now this might look a little bit intimidating, but with this one here, we can actually resolve it into its x and y components. So let's start off with this guy. With both of these, we can resolve them into x and y. So for the first problem, x1 equals 70 meters, and that's just because it's simply moving in a horizontal direction. And since it's only moving in a horizontal direction, it has no y component because it's only in one direction. It is a one-directional motion. This part is where it becomes two-directional. So we know for this one, x2, we would do r2 cosine of the angle, which would be 30 meters times cosine of 30. And that would give us, I have all my math over here so I don't have to bring out my calculator. That would give us 26 meters. Now for the y of this component, it would equal r sine of theta. So y2 equals 30 sine 30 degrees. Y2 would equal 15 meters. Now we have two x values and we have two y values. Now we have to figure out how to bring them together. Because what we're pretty much saying, if I was to redraw this scenario, we have, I'll redraw it right here. So we have 70 from the first problem, and then we have 26 from the second problem. We have 15 from the second problem, and that will allow us now to figure out what that is. So all I did was I broke them both down, both of these vectors down into their x and y components. Now I gotta combine their x and y components. So for x total, it would be 70 is moving to the right, so it's going to be positive 70, plus the 26 is moving to the right, so plus 26 equals 96 meters. And if we look here, 70 plus 26, that would make that bottom line 96 meters. Y total would equal, from the first one, 0, because that one's not moving up or down. 0 meters plus 15, and 15 is moving up, so it'd be a positive, equals 15 meters. Well, now we have one x value, one y value. That means we know this value and we know this value. We can now solve for the resultant using good old Pythagorean theorem. So we have r equals square root of x squared, which is 96 squared, plus y squared, which is 15 squared, and we would get, let's see, what do we get? We get 97.2 meters. 97.2 meters. All right, well, now we just have to do one more part, and that is find the direction, the angle that it is moving up. So right here, this theta. I'm going to do it just like we did before. Theta equals inverse tangent of the opposite, which is the y, 15, over adjacent, which is the x, 96. And theta will equal 8.9 degrees. And if you look at this, it is 8.9 degrees above the horizontal. What that means is you start at the horizontal and you move up 8.9 degrees. And we've solved that problem now. I know my crazy hair keeps getting in the way. I apologize. So yeah, we solved it. It's all done. All right, let's take a look at another one, shall we? Oh, here's my rag. Alrighty. Where's my clown? Here we go. So clown runs 10 meters north, turns 37 degrees north of east, and runs 6.2 meters, then turns due east and runs 5.4 meters. What is the displacement? All right, so let's go ahead and diagram this first. So the clown runs 10 meters north, then he turns and runs 6.2 meters, and that is an angle of 37 degrees north of east. Then he turns again and runs 5.4 meters straight east. All right, so what we want to find is that resultant, the total resultant. Now let's start taking a look at this, shall we? All right, so we have three vectors, vector 1, vector 2, and vector 3. I'm going to start off with vector 1 and 3 because they're actually going to be the easiest. So for all of them, we're going to break them down into their x and y components. So for vector 1, he is heading 10 meters north, straight north, which means he does not have any horizontal movement, so his x value is going to be 0. And the y value will be 10 meters. Let's go to vector 3. So again, these are going to be the easiest. In vector 3, he is heading 5.4 meters straight east, which means he has an x movement, but no vertical movement. So that equals 5.4 meters. And since he's moving straight horizontally at that point, he has no y movement. It's vector 2 that's at an angle, which means there's going to be horizontal and vertical movement. So we're going to have to resolve that one into its x and y components. So x2 equals the hypotenuse of it, which is 6.2, cosine of the angle, which is 37. And for that one, we get, there it is. We get 5 meters. And then for the y, it would be 6.2 sine of 37. And that would give us 3.7 meters. All right, now we have to find our x total and our y total. So pretty much we want to find this as our x total, and this would be our y total. If you're wondering, well, how do we get that? Because this x value here and that y value there, that way it makes it into a perfect four-sided rectangle. All right, so x total equals 0 plus 5.4, and 5.4 is heading to the east, so it's positive, plus 5, and that's also heading to the east, so that's also going to be positive. That equals 10.4 meters. Y total equals 10, which is heading north, so that's positive, plus 0 plus 3.7, which is also heading north, so that's positive, and that gives us 13.7 meters. Well, now that we know our x and y totals, we can find our resultant. Because what we're saying is that this value here, that's a 10.4, and this is 13.7. So now we can find our resultant. And that's using good old Pythagorean theorem. So x squared, 10.4 squared, plus 13.7 squared, or y squared. And when we go through and do that math, we get, one moment. Oh, wait, sorry. That was my bad. I misdid that. So that's just 5 meters east. Sorry about that. My math wasn't adding up for a moment. That's just 10. Sorry. I was misreading my problem. I apologize. So, 10 squared plus 13.7 squared would give us about 17.0 meters. So the displacement is 17.0 meters. Now we have to figure out the angle, so the direction. That is, so theta equals inverse tangent of the opposite 13.7 over 10, and that would give us 53.9 degrees. And it is, this is east, it is north of east. All right, not too bad. Let's get one more. We'll make it a little bit harder. How does that sound? Alright. One more that's just a bit harder. So here we have a plane that is flying for 672 kilometers at an angle of 32 degrees north of east. So it is flying at 672 kilometers north of east, 32 degrees. And then it turns and flies for 392 kilometers at an angle of 43 north of west. So if east is this way, west is that way. So north of west would be this way. And that's 392 at an angle of 43. All right, we gotta figure out that resultant. What is the displacement of that plane? All right, it's a little bit scarier, doesn't it? That's okay. We can still work this out the exact same way. It looks scary, but it's not as bad as it looks, I promise. We do have two values that we have to resolve. Let's start with the first vector. I'm going to break that into its x and y components. We have x1 equals our hypotenuse, 67.2 cosine of 32. And that will give us, sorry about that. That will give us 569.9. 569.9 kilometers. Y1 would be the hypotenuse, 672, sine 32. We go through, we solve that, and we get 356.1. So far, what we're saying is this is x1, which is 569.9, and this is y1, 356.1. That's what we found so far. All right, now this one. Sorry, my neck's starting to hurt. That's what I get for doing this on the floor, huh? All right, now I gotta do that one. We have x2 equals 392 cosine of 43. And x2 equals 286.7 kilometers. Y2 equals 392 sine of 43. Go through, solve that, and y2 equals 267.3 kilometers. Now what we're saying for this one is this is its x value, 286.7, and that is its y value. So if we were to take a look at this, take away the red, and we would end up with in other words, notice these two x components. They're heading in opposite directions. And what do we say that means? Well, x total would equal first one, 569.9, which is heading east, so it's a positive number, plus 286.7, but look at this one. It's heading to the west. It's a negative number, so we're going to subtract the 2. And that will give us 283.2 kilometers. In other words, since this is subtracted from that, we are trying to find this triangle, which is still a right triangle, and find that theta and that resultant. So y total equals 356.1, and that is heading north, so that is positive, plus 267.3, which is also heading up, so that's also positive. And we get our grand y total of 632.4 kilometers. We now have our x and y values. We can now find our resultant. So square root of x squared plus y squared. And our resultant would be 692.9 kilometers. And the direction would be opposite, which is once again y, so inverse tangent of the y value, 632.4 over the x value, 283.2, and that will give us an angle of 65.9 degrees north of east. Because if you look here, this is east, and it is heading above that, towards the northern end. All right, hopefully not too bad, not too scary. If you have questions, see me in our Google Classroom or email or actual class. But in the meantime, you guys, just stay awesome, stay amazing, and I will speak with you later. All right, take care. Bye-bye.